Good evening, guys. Today I will teach you algebra. Day before yesterday I taught about the basic of groups. So I will continue the same class. See you. Today I will give one example of a group. Groups. Basically, I told the definition of the group, but I will give some examples. You can understand easily, right? See you. Is it a group or not? You have to find out, right? Fine. Example 1, n comma plus is a group or not. Okay. For group, how many properties you have to prove? 4 properties. Number 1, closure property. Number 2, associative property. Number 3, identity property. Number 4 is the inverse property. But remember, first 2 properties, closure and associative, mostly satisfies to each and every number system. Okay, only 2 we have to prove. Those are identity property and inverse property, right? Okay, fine. See, identity property. What is the here given to us? N is the numbers, natural numbers is given to us. I will choose 2 elements. Let 2 comma 3 belongs to n. Otherwise, we are proving identity property now. I will take only 2 elements, only one element. 2 belongs to n. Okay. Okay. For 2, what is the identity element of 2? Remember here, very, very important. You have to remember this condition. There are 2 identity elements. Identity. What are those? Number 1, additive identity. Additive identity. The value of additive identity is equal to 0 when the binary operation plus is given. What is that? Binary operation is the plus. The binary operation plus, the value of e is equal to how much? 0. Okay. Second one, multiplicative identity. Multiplicative identity. Right? Here, e value is equal to 1. Multiplicative means the binary operation will be into multiplication. Okay, fine. So see here, 2 belongs to n. There exists e is equal to how much? Can you tell me? E is equal to 0. Why? Because the binary operation is the what? Plus 0. So can you tell me 0 belongs to n? No. 0 does not belongs to n. Right or not? If the identity element does not belongs to n, we can tell that n is not a group. Why? Out of these 4 properties, if any one property not satisfied, then we have to tell that it is not a group. Understand? Therefore, n comma plus is not a group. Have you understand? Write down. Next, I will teach you another example. See your example 2. Is r comma into a group? asking question or come across a group, I will find out. Only two conditions. First two, okay, they will satisfy. First one, I will teach you identity. Identity property. Understand? See. I will choose one element from real number. R is the real number, right? Let 3 belongs to R. There exists what? Identity element. E is equal to, can you tell me what is the value of E? Is equal to 1. Why? Because here the binary operation is the what? Multiplication. Right or not? For multiplication, E is equal to how much? 1. 1 belongs to where? R. We know very well, right or not? Because R contains all the elements. Okay, fine. Such that 1 into 3 is equal to 3 into 1 is equal to 3. Condition satisfied. Fine. Next what? Inverse property. Inverse property. I will choose one element, right? Fine. 3 belongs to R. There exists B is equal to, can you tell me? Like that, we got two identity elements now. One is additive identity, another one is a multiplicative identity. Like that, for inverse also, two elements are there. One is additive inverse, another one multiplicative inverse, right? See here, I'm writing here, additive inverse, additive inverse. B is equal to how much you know? Suppose you are taking one element, 2 belongs to any set R. B is equal to, this implies B is equal to how much you know? Remember, minus 2. That is additive inverse. For multiplicative inverse, remember, multiplicative inverse. B is equal to how much? 2 is the element of R. B is equal to how much? Reciprocal of the what? 2. That is 1 by 2. Remember, right? Fine. Like that, you tell me 3 belongs to R. Okay. B is equal to how much? 1 by 3. Why? Because the binary operation is the what? Into. So you are getting multiplicative inverse. So B is equal to 1 by 3. Can you tell me B 1 by 3 belongs to R or not? Yes. This implies 3 into 1 by 3 is equal to 1 by 3 into 3 is equal to how much? 1. Condition satisfied. Right or not? Therefore, R comma into is a what? Is a group. Have you understand? No doubt. Hi guys. Now I will tell you properties of groups. See you. Properties of groups. These are the main properties of groups. Number 1, uniqueness of identity. Uniqueness of identity. Have you understand? This is one theorem. What he will ask, you know? State and prove. The uniqueness of identity elements are unique. State and prove the identity elements are unique. Are unique. In examination, he will ask like this. Okay, now state and prove the identity elements are unique. Okay, I will prove this one first, right? Fine. Proof. Right? Okay. Suppose G comma star be a group. In place of star, we can take plus or into whatever may be, right? Okay. Let E1 and E2 be two identity elements in G. What I have taken? E1 and E2 be two identity elements in G. What to show? To show that these identity elements are what? Unique. E1 is equal to what? E2. Understand? Okay, fine. I will prove this one. Okay. Now, E1 is the identity element in G. So what is the identity property? This implies for all A belongs to G, there exists identity element. What you have taken? E1 belongs to G such that A star E1 is equal to E1 star A is equal to how much? A equation 1. Understand? Okay, fine. Similarly, E2 is identity element in G. This implies for all A belongs to G, there exists E2 belongs to G such that A star E2 is equal to E2 star A is equal to A. Equation number 2. Understand? Right. Okay. From equation 1 and 2. 1 and 2. See here, on the right hand side, both are equal A. If right hand sides are equal, automatic left hand sides also equal and middle one also equal. Right or not? You can choose any one. So I will take left hand side. A star E1 is equal to A star E2. Have you understand? Write down this first. And see you in these two elements, in two sides, A is equal. Equal or not? So before that, I will tell one property in group, that is cancellation property. Cancellation property in group. There are two cancellation laws in group. One is left cancellation law. LCL means left cancellation law. How is that? See, A star E1 is equal to A star E2, in the left sides are equal, automatically these two will be cancelled. So this implies E1 is equal to E2. This is said to be what? Left cancellation law. Understand? Another one is the right cancellation law. What is that? See, E1 star A is equal to E2 star A. Right sides are equal. So right side will be cancelled. So this implies you are getting E1 is equal to what is that? E2. Have you understand? So here left sides are equal by the property of what? Left cancellation law. Since left cancellation law, what you are getting? Implies E1 is equal to E2. Have you understand what you have to prove? This only. Right or not? Hence proved. Hence proved. Write down. Now I will teach you another property, that is uniqueness of inverse. Second property. Uniqueness of inverse elements. Okay? Fine. This is also very important. Okay? Fine. I will prove this one. Proof. Suppose G comma star be a group. Let B1 comma B2 be two inverse elements in G, to show that what to show? B1 is equal to B2, right? Now B1 is the inverse element in G. This implies for all A belongs to G, there exists B1 belongs to G such that A star B1 is equal to B1 star A is equal to how much? Remember, the value will be identity element. What is that? E. Right? Fine. Give equation number 1. Similarly, B2 is the inverse element in G. This implies for all A belongs to G, there exists B2 belongs to G such that A star B2 is equal to B2 star A is equal to E. Equation number 2. Write down. Sorry. From 1 and 2, right hand sides are equal, E and E. This implies left hand sides also equal. A star B1 is equal to A star B2. Have you understood or not? Okay, so here in both the cases A is equal. Okay, in left sides. By left cancellation law, what you are getting? B1 is equal to B2. Why? Since left cancellation law. What you have to prove? This only prove. Hence proved. Hence proved. Okay? Now I will teach you another property. Property number 3. That is socks and shoes property. Socks and shoes property. What is this socks and shoes property? Very important. See statement. Statement. If A comma B belongs to G, where G comma dot be a group, then AB whole inverse is equal to B inverse A inverse. Very, very important theorem. It is called socks and shoes property. Right? I will prove this one. Okay? Fine. Prove. Given that G comma dot be a group. Dot is a what? Binary operation multiplication, right? Be a group. For all A comma B belongs to G, this implies what? AB belongs to G. Which property this one? Closure property. What is that? Closure property. Have you understand? Fine. If AB is one element belongs to G, this implies AB whole inverse also belongs to where? G or not? Which property? Inverse property. Inverse property. That is inverse element. Fine, because G is a group, right or not? This implies AB into AB whole inverse. How much? Identity element, that is equal to E. E is equal to how much? 1. E. That is equal to 1. Understand or not? Give equation number 1. Okay? Fine. Write down. Start. Now, A comma B belongs to where? G. This implies A inverse belongs to G and B inverse also belongs to G. Why? Since inverse property. Inverse property. Okay. Fine. Now what I will do here, I will consider here AB into B inverse A inverse. Okay? Because when AB belongs to G, A inverse B inverse belongs to G, closure property. B inverse A inverse also belongs to where? G, that is a closure property. Why you are taking this one? For proving the theorem, right? Fine. So this is equal to how you are writing? See you. I am writing this one A, B inverse into A inverse. Which property? Associative property. Associative property. Okay, fine. This is equal to B inverse is equal to how much? 1. So A1 means E. Means I'm writing 1 directly, no problem. Right? Fine. That is equal to A inverse. Understand or not? A inverse is equal to how much? 1 again. Right or not? So you got here AB, B inverse, A inverse is equal to how much you got? 1. Equation 2. From 1 and 2. From 1 and 2. From equation 1 and 2. Left sides are equal, right sides are equal. Automatically, left sides also what? Equal. What is that? AB whole inverse is equal to this one. AB into what? B inverse, A inverse. Understand or not? Here again, which cancellation law? Left cancellation law. What we are getting? AB whole inverse is equal to what is that? B inverse, A inverse. Hence proved. Left cancellation law. Hence proved. Understand? Bye.